All right, so let's wrap up this algebra here. Let me just grab all this math to get to the next page. Did I make a page? Yeah, I made another page for this. All right, so let's just throw this right here. And let's just move forward with this. So I can basically say Vs minus I1 times R1 plus J omega L1. And I can say plus J omega M times, I've got another J omega M, so I can just square that, times I1. And then that whole thing is over R2 plus J omega L2 plus ZL. Okay, I can obviously set that whole thing equal to 0 still. And now what I can do is I can factor an I1 out of both of these terms. So I can, let me just add this over to the other side. So we'll say I1 times R1 J omega L1 minus I1 times J omega M squared. Sorry, this is getting ugly. I don't like all these parentheses. That whole thing over R2 plus J omega L2 plus ZL. And of course I can factor an I1 out of this and I just get Vs over I1 equals R1 plus J omega L1 minus J omega M squared divided by R2 plus J omega L2 plus ZL. That right there is the input impedance of this transformer. Pretty hideous, if you ask me. But this is just a standard two-winding transformer with input resistances, and we see this relationship for the input impedance of the transformer. So you might get a question like this asking you to find the input impedance. All it's asking you to do is basically find this ratio Vs over I1, or whatever the current is flowing out of that voltage source, because we're typically interested in trying to figure out, right, if I have a source and I connect it to some circuit, some complicated circuit like this one, can we just represent that as some equivalent input impedance and then determine how much current is being drawn from the source in that case? Almost always we can, and that's exactly what you see here, is that we're just drawing an equivalent circuit where we're replacing everything to the right-hand side of AB with just some equivalent input impedance, okay? So that's kind of what we're doing here. If you have any questions, just let me know. This is just another exercise in utilizing the dot convention and solving a circuit using magnetic coupling. Let me draw these two lines here just to stay consistent. And I'm going to go ahead and call this video good, and we'll see you guys in the next video. And what do we got in the next video? Oh, we're starting to talk about the ideal transformer, okay? So we'll talk about the ideal transformer in the next video.